graph paper since we're going to be doing drawing. I do have graph paper up front too. 6. Okay, it feels weird to write 6 now. Can't remember if it's EI or IE. What? I mean, you could have if you wanted to, but there's some. Well, I suppose those holes already punched in them. I've heard these referred to as Riemann sums or Riemann sums. So if you're watching different kind of videos, since I know some of you guys like to use Khan Academy, some of you like to watch the AP Classroom videos, you know, whatever's there. I've heard it pronounced both ways. It honestly is a really fancy name for just finding area of rectangles. So it's not bad. They're just really slow. So in terms of difficulty, this is a great start for us. This is going to be super easy. And so you'll probably like that. I'm sure after a week off, I would be shocked if you guys could tell me what was on the last test even at this point. Like even what the test was on. So if you said derivatives, if anything, we'll call that a win. We'll call that a win. The good thing was it was the end of derivatives. So we are no longer doing derivatives directly. We are going to be starting antiderivatives, which sounds worse. Also known as integrals. So they're the opposite of derivatives. Well, we'll start with this, and we'll start semi-easy. Notes are going to go super slow today because I've got to draw everything as well. I thought it would be kind of mean of me to use the packet and force you guys to write all of that down, so I'll just kind of write it with you. Let's go straight forward to start with here. Let's make a straight line. I can't really tell where that is. Go right there. We'll make the straight line end at 5, 3. I guess I'll just go by 1 since I already wrote that. I will pretend this is walking or something. So it's slow. Actually, no. I have no idea what it is in feet per second. I was thinking miles per hour. What is it? Is it like 60, 55 miles an hour is 88 feet per second? Do your driver's training instructors not talk to you about that anymore? No. Okay, then I'll just, never mind. So we did this quite a while ago where you guys found the area under a curve, or under a graph. So let's, oh, actually, no, that was dumb. Let me erase that one. Let's make it easy and go from 0, 1 to 5, 3. So we found this area. Like, do you guys vaguely remember doing that? Yeah. Okay. If I remember correctly, you had to find like the area above the axis or below the axis, something like that. I can't remember what it was for right now. I think it was position, velocity, acceleration type problems. I guess the main thing I want you to get out of this, do you remember how to figure out what the area stands for? Let's pretend this is a nice, easy rectangle. How do you find the area of the rectangle?
Like my waist height.
Base height, length, width, whatever you call them, right? So you're basically taking one dimension times the other. So this blue shaded area would be found by taking seconds, which is the bottom dimension, times feet per second. So your answer should come out as
5
feet.
Yeah, sorry.
True. I don't even know what the number is. Let's pretend your math teacher was smarter and would have done the actual numbers too. But in terms of what it stands for, that shaded area would represent feet. So it would represent how many feet you traveled. Because the bottom dimension was seconds, the side dimension was feet per second. So area, in general, is base times height. So you multiply them. We're okay with that? That's the big idea you need to take out of that. This one isn't obviously a rectangle. I guess it's like a trapezoid, which I wasn't really intending, but we can find the area of this by just geometrically. Sounds like it's 5.
It's just my guess.
Oh, did anybody actually figure it out yet? Should we go over how to figure it out? Did you guys forget that much over spring break?
I don't think I forget that. I don't remember.
Oh boy. Okay, I feel like I should wait until some smart person can figure this one out. And if not, I should go to geometry and grab somebody from 2-3 years ago who could figure it out.
The reason I guess 5 is because I just did base times height, so I did 5 by 1. But that's, oh no, you do so it'd be 15. No, I just don't know.
So 5 by 1 would be that bottom part.
Yep.
And then what's the shape above that?
Try.
Triangle. So it would be 5 times 2 divided by 2?
Okay.
Oof. This is gonna. Are we gonna take some multiple days here to like remember math?
So it'd be.
All right. So looks like we've got 10. So whoever this person was traveled 10 feet in 5 seconds time. I feel like that's really slow. Yeah, that's got to be really slow for 5 seconds. That's like my pace. These get harder though, right? So if this was a rectangle, that was the easiest. This one was a trapezoid. Supposed to be easy. We're breaking our brains back into it. What would make it harder?
Something that doesn't have like a definite, like you can't really break it down super easily. Or does that make it a little harder, like that?
Yep. I think you're trying to say it correct. Basically, if it's non-geometric shape.
Yeah.
Okay. So that's what we'll draw next. Wait, what the heck? What? Oh. Trying to think in my head to make an equation work out nice. This is supposed to be an upside down parabola. think I did that right. No. What would make it cross at 4, 0? So that'd be 16, that'd be negative 8 plus 4. Let's just pretend this is upside down parabola. Let's spell upside down right. Parabola. There, now I don't need correct numbers. Whatever the equation is, doesn't matter. Let's say this represents the same thing. And obviously, I'm just trying to pick easy units because it's kind of something you can somewhat visualize. Obviously, it's not always going to be seconds and feet per second. But if we had the same goal in mind, actually, let me get the highlighter. Is this going okay for you guys to draw it on your own, I'm assuming?
Yeah.
Okay. I'm trying to work with easier shapes and numbers that are nicer since it's not pre-drawn. Okay, so we want to find that area because that would represent the total distance traveled for this problem. I guess the downside to this one is it looks kind of like a circle, but it's not actually a circle. So that's why I was trying to give you an equation that was a parabola. If it was a circle, we could still do this geometrically, where we could do a quarter of the area of a circle. Our goal is going to be to estimate this area using kind of easy methods. So what we're going to start with is rectangles. Well, that actually worked out okay. Oh, so close. Now, obviously those rectangles aren't going to be the correct answer, but they're an estimation of the answer. Oh, I really need an equation for this. Whatever, we can estimate it from the graph I made, I guess. Area of the first rectangle is approximately what?
8.
Oh, actually, no, that one's going to be exactly 8, right? So we'd have 4 times 2. Second rectangle looks like about 3.5-ish times 2. Okay, naturally the next question is going to be, how can we get a more accurate estimation? More rectangles. Because I purposely tried to draw 2 rectangles to make them extremely not close. If I decide to draw this with more rectangles, well then this should, how do I erase? I don't think I can erase this. Let's do that. And I know this is kind of garbage for you guys drawing your own notes. I don't have a better way to do it. But I am recording this, so you can at least watch the video later, you know, if you're not able to draw everything. Okay, so let me draw, I don't know, should I do 4? Sure. I know you guys probably don't care anyway. Okay, so this one, those don't look super evenly. Oh, you know what? They're not evenly spaced because I just freehand drew the tick marks at the bottom. So we can still estimate this one. Let's do a different color. So this one's 4 by 1. This one's like 3.75 by 1. 3.25. I can't really tell. You guys can see easier from your view. What's this one at? Like 2.5?
Yeah.
I was really confused what was going on. What does that come out to be? 7.75, 10, 11, 13.5? Did anybody else even add it up? Oh, wow. You guys are going to be destroyed this trimester if you don't like try to do any math. Is it 13.5? Okay. Then naturally the next one would be more rectangles. That's why this is really slow. Not only do we have to draw it, we have to calculate it. The actual math from this is super easy. It's the process behind the whole thing that's You know what? I think you guys get the idea.
Did you do it sideways as well?
No, that's actually a good point. The reason we're not going to do it sideways is because we couldn't use the function values. So what's going to happen is you're going to have an actual equation here, and you're going to use the equation to determine the correct height. So we're just kind of estimating it right now because I didn't have an equation. But that also leads us to something else here. Can I erase? How does this?
So it just be negative 1/4 x squared plus 4.
Hold on. Is that what you said?
Yeah.
16 for. Yeah. Good call. Where were you when I wrote this down? And for what we're doing right now, the example's not a huge, the actual equation isn't going to be a huge deal. Let me draw the 4 rectangles again. So I don't know if you guys noticed me drawing the rectangles. Oh. But I created the rectangles a certain way. So the rectangles I drew had an overestimation, right? Because they're bigger than the shape. So I would actually expect the real area to be less than 13.5, like 12.5 or something like that. But I can draw the rectangles differently. So this drawing of the 4 rectangles would be an underestimation. Now, do you want me to kind of do the dragging part again? I don't know if you noticed, like that's actually kind of what determines the height. Let's pick the one right here, just this second interval. This was the first rectangle I drew. How did I determine the height?
The lowest point that it touches the curve.
I'm not sure if you might mean it correct, but which side of the rectangle is determining the height?
The right one.
The left side. The left side of my rectangle is touching the function. So when I dragged my rectangle, I dragged it up until the left-hand side touched the function. That's going to be known as left endpoint estimation. That's one of the three methods. That is horrible. Don't worry, in the middle of our test, we'll just have an extremely, extremely loud bell.
Isn't there four methods?
Kind of.
They kind of left and right is one.
No?
Oh.
So this is going to be left endpoint method. Oh. That's stupid. Okay. Now, if I drag the same rectangle, but I stop right here, this is going to be known as right endpoint. So that would be one method for estimating the area.
So when you're doing those like endpoint methods, you're waiting until said endpoints, like the right endpoint touches the curve? Or you just stop doing it?
Yep. Yep. The third method would be this one. Where am I stopping the rectangle?
Middle.
In the middle of my rectangle. So they call that midpoint. Oh, that's not a marker. Who was mentioning four methods?
What? Did we do the trapezoid one?
Okay. So there is a sort of fourth method, but they no longer test on it on the AP test.
It was on the conference.
Oh, like on Khan Academy
Yeah,
or
it's like one of
AP
the-
Classroom? Yeah. So there is a fourth method that they used to teach. Not that it's necessarily harder, it's just annoying. But it's horrible for me to draw. So instead of drawing rectangles, you draw trapezoids, which gives you a pretty good estimation, because then there's very little under or overestimation. But we no longer have to do that on the AP test, so it just, rather than just trying to cram you full of everything, I'll probably just leave that off. Now, the other reason that this is removed is if you estimate what the left endpoint, which was right here, and then you estimate with the right endpoint, which was right here, and then you average those two answers, it's the exact same as the trapezoid. Because the trapezoid was made by creating a triangle from that point to that point. So both of them could find you that same answer. Oop. Whatever, I'm going to leave it. Are we okay with the actual like drawing of things for right now, probably? So it's an estimation when we use rectangles. It's a better estimation when we use more rectangles. And then that would lead us to the next step, which at the beginning of the year we learned how to find answers when infinite number of things. This is not correct notation, I'm just writing it. Do you guys remember what the sum notation stands for? Sigma? It means you add up the things. So if I have this sigma notation here, this would mean I'm going to add up an infinite number of rectangle areas. And then that should find me the exact area. And then we're going to start using different notation. That was a bad one. It's a weird F. This is the integrand symbol. Most people will draw it as a really bad S, like me. So this is going to be the notation that we're going to use for an infinite number of rectangles, and it's going to stand for the exact area. So even if we're using a curve, no matter how bad of a function we're using, we're going to be able to find the exact area underneath a curve. That's going to be the goal. We're not going to get there right away. This is kind of our goal for multiple days. We're going to start by doing estimation of rectangles, which is super annoying but easy, and they are on the AP test. So, I mean, you actually do get some easy questions on the AP test. So let's try to do it. What time do we actually get out?
4.
Okay. We definitely have time for a problem. Let's do one problem. My guess is that's all we'll get in. But let me come up with an equation that we can use. Why don't I stick with a parabola since you... No, let's go trig, because you guys hate trig. I know, that's so nice of me. Mm-hmm. Oh, that's why it's writing weird. You guys absolutely need practice at trig. A total of 2 people got the question right on the test. The very last one.
Is there only like one perfect though?
One perfect pre-curve.
Yeah.
Yeah. I don't know if Mr. Sofer's finished correcting his yet. But yeah, he has a curve as well.
What was the curve? What did we curve up?
Hold on. I'm trying to think of the equation that will work nice here. Should we do left, right, or mid?
Left.
Yeah. Yeah.
Left?
Left.
Okay. Okay, so you're not necessarily going to have to decide this information on your own. You're generally going to be given an equation. You'll be told how many intervals to make, and then you'll be told, what method to use. Unless for whatever reason you're given the choice on what method to use. But for the most part, you're generally given all this information. So maybe I'll wait till you guys get here, and then we should, I don't know if we should try to draw it together. Do you guys feel like you're at the point where you can figure it out already? Should we do this one together? Okay. Given that you couldn't find the area of a trapezoid to start with, we should definitely do this together. Okay. It was 3 points. No, I think Mr. Stover didn't have the last question, though.
It was optimization.
No, there was a question, a trade question.
Oh, I don't think so.
Yeah, if I remember right, I think he said he ended up taking it off. I kind of told everybody, I kind of gave I gave my classes the equation to put in place of it. So my curve is different than his because of that question. We also haven't figured out a good way to get the test back to you either, because everybody had to switch. It's kind of a mess. Everybody changing it every trimester has made everything really hard. Okay, are you guys here where you have this drawn?
Yeah.
All right, good. Let's go with Caden. What should be the height of my first rectangle? If the left-hand side is what we're using, so left endpoint. Perfect. Okay, so I'm going to draw my first rectangle. I'm going to stop when the left-hand side hits the function. And then 8 intervals. Oh, I guess I didn't even say where to go from. I'm going from 0 to 2 pi. So the 8 intervals would make it pi fourths. There we go. Do you want me to go over how to figure out the width of the intervals when it's non-standard? Like most of the time, it's not going to be a width of 1 or something easy. Okay, so if you want to figure out the width of each interval, you're going to have to take the length of your interval, so b minus a, and then divide by the number of intervals. So in this case, I knew it was going to be pi fourths just from that information. I think a lot of you were able to just look at the picture and know how wide to make it too. But if you're given some information that doesn't fit nicely into your picture, you do b minus a, maybe I'll write that out. B minus a divided by n is how they usually write that. Okay, second. Maybe I'll write the area of my first rectangle. My area of the first rectangle is 2 times a width of pi fourths. Okay, whatever that is. Caden, pick the next person. What was your name again?
Aiden.
Aiden?
Yeah.
Oh God, Caden, Aiden, Caden. Really? You guys are awesome for picking your spots like that. Okay, so Aiden, how do I figure out how high to draw my next rectangle?
I'd go up above right there to where it hits the graph.
Correct, but how do I know that height? Because we need to know the actual height. What you said was perfect, but we have to have a way to be able to figure that out. So it hits right here, right? Yep. But I do have a way of figuring out that height.
Plug the x in your equation.
Good. What x?
Pi over 2.
Close.
Pi over 4.
Perfect. We're going to do f of pi over 4. And so you're absolutely going to need your calculators, and there's going to be lots of decimals. Like, a lot of these answers just don't work out nice. It's just going to be a lot of decimal info. Technically, this first one, I wrote 2 because it was a nice, easy number we could see, but how would I have figured that one out if I didn't know it was actually 2? What would I have plugged in the function? 0. So that would have been f of 0. Okay, next rectangle, Aiden. Without calling on Caden, can you call on somebody else for me?
Grace.
Okay, Grace. What's the height of that third rectangle? Good. And then you guys most definitely start seeing the pattern, I'm guessing. I went from f of 0 to f of pi over 4 to f of pi over 2. Now this one's going to be f of 3 pi over 4. My drawing is much worse than that, though. When I'm all done with this one, how close is my answer going to be, do you think?
It's gonna be pretty close.
Why? I would guess that too, but why do you think so?
This is a mix of over and under.
Yeah,
That's in there?
because this function is, well, it's symmetrical, but it goes up and down. So we have positive concavities and negative concavities that kind of balance each other out. So our overestimates and underestimates end up kind of being the exact opposite of each other. So I would think this estimation's pretty close. Now here's the pain in the butt part, is actually typing this in and figuring it out. These questions go really slow. On the AP test, these questions frequently are given to you as a table so that everything's already calculated out. And then you would have to basically just use the numbers that are there to find the answer so that you don't have to go through and find everything. So if I could present this possibly differently to you, this first one I wrote 2 times pi fourths. What is 2? That was f of 0. This would be f of pi fourths times pi fourths. This would be f of pi halves times pi fourths. Every single one of these is going to be times pi fourths. So what ends up happening is you get all of the heights times pi fourths. So that's one slight shortcut that can help you. If you have even intervals, you can hold off that times the interval until the end. That's one slight shortcut. And then eventually, if you ever really start to get bored, instead of finding the height repeatedly, this can be a summation, because we're taking all of the heights and then adding them together. So this could be like, say, the sum from 0 to 7 pi fourths. Now, this isn't the real notation at all, but that's basically what you're doing, is you're adding up all the function values from 0 to 7 pi fourths. And there's definitely a different way of writing it, but I don't want to like throw you into overdrive and panic today, because I feel like if I gave you all the right notation, it looks a little scary. But that's what we're doing. Okay, we get done at 04, you said?
Yeah.
I feel like that was probably plenty for our first day. Even though we didn't actually do much math. Like you guys did thinking. You did a lot of thinking, but not much actual math. How about this for homework? Since we don't have a packet, why don't you finish this question? And I think that's fairly decent for homework. It's probably going to take you 15 minutes on its own. Because I want you to actually get used to going through and doing the calculations and figuring things out. And then this way you guys can check with each other tomorrow. And then I can tell you the exact answer and see if it's close.